Hello, I am Dr. Ravindranath Rajotia, and in this video lecture we will be discussing about the PIC programming part 2. We will discuss some program like comparing the two numbers, finding how many number of number of ones are there in the given literal, and adding the numbers. So let's start with the program directly. So in the first program, the first program will be write a program to find the smaller of the two numbers smaller of the two numbers, and let us assume that the numbers will be, let's say, 27 and b is equal to 54. And once you compare it, place it in the file register at location, let's say 0 cross 20. This is the address. So let's start with it. So let's take two numbers. Let's say val 1 equal decimal 27, val 2 equal decimal, let's say number literal is a literal 54, and let us take a place to store that value. Let's take this name as a LREG. This you can take as any number equal, let's say 0 cross 20. This is the location for storing. So here we will store at this location, this is a file location, store the smaller of the two numbers. Smaller of the two numbers. The program will be, we will move one of the numbers into the working register. For that we write move the literal pointed out by the val 1 into the working register W accumulator VAL1. So this value which is pointed out by VAL1, so this is brought into the accumulator. Now move F. So here what exactly happens? So W will be equal to 27. Then I write move the value of the accumulator, which is nothing but 27, into the register file, and the register file, let's say this file referred by the address. So let me name this as LREG. So we know that this location which is referred by this name is also equal to 27, since we have moved 27 into the W and W into this register file. So we have emptied the accumulator, then we move another literal, the second literal, into the accumulator because the accumulator is now free. We will move the second value, that is 54, into the accumulator and use the instruction called as a compare CP, compare file SLT. So this instruction is going to compare, the file register with the working register, that is accumulator, with the WRAG working register, and skip. The instruction is skip if less than, and skip the next instruction, skip the next instruction, skip the next instruction if the file register is less than the W register. So if F, the contents of F is less than W. So this is what exactly this instruction will do. So how do we write this instruction? We write this as compare file skip if less than, and which file we are comparing? We are comparing now accumulator has the number 2 and file LREG has the first number. So we will compare the file register which is referred by LREG and the second argument which is in the W, and skip if less than the W register. So the next instruction will be move WF, move WF LREG. So this instruction will place the smaller value in the working in the register LREG. So this is going to place the smaller of the two into the LREG register. So this is the one program that we wanted to cover up. The second program that we wish to take up is, so let's take another example, the example 2. So let's say example 2. In this example, we want to write a program, WAP, write a program to find the number of ones in a given byte. In a given byte. This is the second program that we want to take. So let's start with it. Let's say R1 equal a 20. So this means this is a file location. So this is nothing but the file register location. So this is a location for the number of ones. For number of ones. Let's take another variable named as a equal count equal 0 cross 21. So this is the file register location. This is the location for the counter. So this location or referred by count will store the counter. Then we want to have another variable, well, give it as any name, well res equals to, let's say 22. This is the file register location for the byte, the number that you are given byte, for the number or for the given byte. Now let's start writing the program. BCF bit clear file status is the name of the file, comma C. So of this status register, the bit clear, bit C will be clear to 0. C will be equal to 0. Now we will clear the file named by R1. So this instruction will make R1 as equal to, R1 keeps the number of ones because the result number of ones is to be kept in R1. So initially we make this as equal to 0. Then we move the literal into the W register 08. Move the literal into the 08. Since R1 is for since this count is used to number of bits counter. So this will set the count value into the accumulator, which we will move into move the value w, which is this value, into a file whose name is count. So the number 8 will be stored into this count. Then the given byte, let us assume that we have any byte, move literal into the accumulator, and let's assume some number, let's say hexadecimal 97. So this is W will be equal to 10019 and 011197. Then we will move this W into this register or this variable. Move the W register into the file whose name is val.reg. So this val.reg is also equal to 97. Now let's write down the program. This will be the label where we have to jump back, rotate with the carry, rotate left RLC through carry the file. Which number you want to rotate? I want to rotate this number which is in the this file, that is val reg f. So this will rotate val reg through C only once. And next write branch if no carry, अगर कोई carry नहीं है, branch if no carry to the place next. If the C is not set, then move to the next. But if the C is set, then I will increment the file, which is the file R1. R1 was initially, you made this as equal to 0. So if C is equal to 1, then R1 will get incremented, R1 plus plus. So otherwise, one operation is complete. You can write decrement the count, decrement the file, which is named by the count, the file. And this is, you can continuously move this until the count value is equal to 0. So I can move this branch, and if not 0, go back to again. So this way, this is the second program that we have seen. So we have covered up two examples in this video. The first example was nothing but write a program to find the smaller of the two numbers, and see what instruction we have used here. We have moved two numbers, one number into the W register, and then we moved this into the LREG register. Then we moved the second literal into the accumulator, and now we are comparing, compare. So you have compare file and skip if less than equal to 0. So this will compare the F with the W, and if F is less than the W, then we will skip the next instruction. Otherwise, W will be stored into the L register. The second program that we have seen is to count the number of ones in a given number. So for this we took the location, the variable R1 at this location 20, count location 21, val register location 22. Initially we clear the status register, the bit number C is 0. We clear the register R with 0 0. Then we move the literal 8, because this is a number of times we have to count. The byte contains 8 bits, so this will be moved into the count through the W register. Then we move another byte into the working register and store this at the val register. Now we will move left right, rotate left through the carry. So we will rotate this number. So this W MSB 1 will come into the C register, and whenever it so happens, branch if no carry. If this was not a carry, then you branch to the next, and if it was a carry, because in this case it is a carry, so R1 will be incremented, then decrement the count and branch if not 0 to again. So that's all in this video. Thank you for watching.